And now we are going to have a few short talks, short 25 minutes. The first one is the one of Dr. G.Jozsa and colleagues about the WSRT HALOGAS survey.
Yep. Good afternoon. Well, I'm going to talk about an H1 survey that we are currently that is currently in progress. It's the WSRT hydrogen accretion in local galaxies survey, which is a deep H1 survey of a quite large sample of galaxies. Okay. Their faint neutral gas population. The PI is G.Jozsa, and since this is the WSRT telescope, many people are from Astron in our group, and of course the usual suspects in this context. Now, what I'm going to present is rather an overview about the motivation and a first glance at the survey, since it is at the moment in progress. So what is the faint neutral gas sensors that we have right now? Well, of course, we have the HVCs, high velocity clouds that are detected for our galaxy, for the Milky Way. More well known is complex C. They are actually a halo belonging to the Milky Way, a halo population, since in the recent years their distances have been bracketed, so it is quite clear that they belong to the Milky Way. Their characteristics is a low metallicity and mass up to 10 to the 7th solar masses for complex C. Now also other galaxies show the same or similar structures. Although one must say that not many galaxies have been observed that deep to show that such high velocity clouds or analogs of the high velocity clouds might be present in other galaxies. How can you see them in those galaxies? Well, this is an H1 very deep observation of NGC 891. This is more or less the textbook example, or one of the two textbook examples. These are two channel maps, so the intensity, H1 intensity measured independence of radial velocity. What you see here is a huge H1 cloud complex that makes in principle the analog of complex C in mass, that would be 10 to the 2 times 10 to the 7th solar masses, but also distinguishable in mainly in velocity, such a few small clouds that you also detect in those galaxies. Companions of galaxies, actually here, there is also shown, and a large H1 halo that is distinguishable while these beards are observed. So these accretion taking place for the galaxies out in the model alone, and they also have shown that in principle. Now, I've been to iron, which may be a title feature. This is again a position velocity diagram along this line, so it's quite asymmetric. And instead, we can only glance at the data that we have now. We are performing a very deep survey using very much observing time from the WSRT synthesis radio telescope. We reach a sensitivity of 2 times 10 to the 19th atoms per square centimeter at a 5 sigma level. So this gives us really the handle on detecting very faint structures in H1. And the first inspection, in a first inspection, we see this extraplanar gas in many of the systems, if not in all. But a massive rotating halo like NGC 891, which is used as a textbook example, is not seen. While we see less massive halos that we haven't quantified well enough to say anything about whether these are at forbidden velocities or not, so to say. And we see HPCs. Of course, if you had a look at this image of NGC 891 in the optic AGP stars, what one also needs is very sensitive optical observations and complementary observations. These are done in the optical with the INT to trace the star formation, make the connection to the star formation. You need far UV, and this is done with galaxies for a few of those the galaxies that are being observed. And not least, it should be announced that we will make the data publicly available. There's so much to do with those data that we cannot do ourselves at the end. So at some time in about, say, a year or 1.5 years, those data will be made publicly available. They will become all. And at the moment we are planning to do this one by one, so put them on the web. To be used for everyone. This is a nice picture of George, not of George, but that George has made. And, well, stay tuned.